हेलो गाइस, कैसे हो आप लोग? हेलो. So we are in a new setup. I'm taking this class from my home. This is the setup which I wanted to try for quite some time, right? So let's see if I am audible. Let's see if I'm audible. Am I audible, guys? Am I audible? Please say yes if I'm audible. Just a second. It seems to be working. It should work. I don't know why it's not working. Yes. Hello. It seems to be working. It should work. Perfect. Yes. So my name is Prashant Jain and this is the third lecture of the IOQM English course. Like I promised, we will be doing algebraic identities in this lecture. So see, like basically algebraic identities are used to factorize, right, expressions. So what do I mean by factorization, right? Let's talk about factorization. Very simple thing, right? Basically, when you have a whole and you factorize it as much as possible, right? You do not write 1 here, right? This is the smallest possible factorization, right? And we stop in numbers we stop when there is a prime number, right? In numbers we stop when there is a prime number. So we are stuck at prime number, right? You do not write it as like this, right? Root 2 into root 2 into root 2 into root 2 into 3, right? You stop here. So basically, at a basic level, algebraic identities will be used to factorize the expressions till the coefficients are rational. For example, you must have seen here that a square minus b square is a plus b. Have you studied this? Have you studied this? Can you please say yes? Have you studied this? A square minus b square is a plus b into a minus b. Have you studied it? Have you seen this? Now, can I say that a plus b is a plus b? This a minus b is root a minus root b times root a plus root b. Now again, I can factorize it like this. So there is no end to it, right? There is no end to it. So that is why we restrict our discussion to rational coefficients. Please write this assumption. Can you please write this assumption? Can you please write this assumption? We will restrict our discussion to factorization till rational coefficients. Can you please write it? Can you please write it, guys? Got it? Got it? I'll keep my mobile here so that I can see your chats. But okay, now I can see your chats. Okay, got it? So first of all, like in the first assignment, we will try to understand homogeneous expressions, right? Homogeneous expressions, right? Homogeneous expressions, right? So we will start where we ended our last lecture. So first of all is two variable, right? So f of a comma b, right? Then a naught a to the power n, a1 a to the power n minus 1 b plus a2 a to the power n minus 2 b square dot an b to the power n. you can see here that this index and power of B are same. If it is 1 here, it is 1 here. If it is 2 here, 2 here. So when we write these expressions, there is some pattern to it, right? There is some pattern to it. And this is the pattern which I am talking about. 0, and if you add these things, 0 plus n is n, 1 plus n minus 1 is n, 2 plus n minus 2 is 1, n. Similarly, this is the defining feature. The sum of degree of each variable, sum of exponent of each variable is n. N minus 1 plus 1 is n, n minus 2 plus 2 is n, and this is n, right? So, in each term, degree of variables is same. Degree of variables is same. This is one defining feature. This is one defining feature, right? This is one defining feature. Yes, yes. As today you have to manage, right? There is a heavy glare on the screen, but I think you will manage, right? It is not that much. So like I am also today, you know, it is 2nd of October, right? Gandhi Jayanti, the offices were closed, so I had to take this lecture from my home. The studio is not up to the mark, but still I did not want to like cancel this lecture. So that is why we are taking this lecture on this screen. Okay. Perfect. Perfect. And anyway, right, the knowledge takes precedence than everything, right? These are just mediums and it's not that much of a deal breaker, right? Perfect. So degree, got it? This is one. So like we'll just write the example. So 2 degree, if I talk about 2 degree, this is a 2 degree expression. If I talk about 3 degree expression, right? This is a 3 degree expression. Getting my point? Getting my point? And there is a very important concept. Homogeneous expression of degree m into homogeneous expression of degree n is equal to homogeneous expression of degree m plus n. Right? It just works like a polynomial. It just works like a polynomial, right? It just works like a polynomial, right? How does polynomial work? If you see a cubic polynomial into a quadratic polynomial is a degree 5 polynomial. It's a degree 5 polynomial. So let's see the application of this, right? I take a 2 degree expression, I multiply it with a 3 degree expression. What do I get? Just simply multiply it. A to the power 5 plus a square b cube plus a cube b square plus b to the power 5. Can you see that this is a homogeneous expression of degree 2? This is homogeneous expression of degree 3. When you have multiplied it, you get homogeneous expression of degree 5. 2 plus 3 is 5. You can see here, sum of the variables, sum of the exponents of the variable is 5. 2 plus 3 is 5, 3 plus 2 is 5. Getting my point? So basically, when we study algebraic identities, it is the study of homogeneous expressions, right? Algebraic identities are essentially study of algebraic identity is essentially study of homogeneous expressions. Got it? Got it? Got it? IOQM result will come. This is live, Aditya Sharma, this is live. Every Wednesday, it is my promise that I'll be teaching in English and it will be live. IOQM result will come on 4th of October, right? It will come on 4th of October. Got it? Perfect. So can you write DN in the chat? Can you write DN in the chat so that I can understand that you have studied it, you have written it, right? Now we'll go on to explore the algebraic identity. Now we will explore the algebraic identity. And I will give you a whole new perspective. I will give you a whole new perspective to look at the algebraic identity, right? I'll give you a whole new perspective. Okay? Okay? Amog, you is saying, thank you for everything. I scored 42 marks. Nice. Glad to hear. Glad to hear. And this time we will be doing for our English learners also. Learners who study IOQM in English, right? I do not mean in English subject, right? Somebody was saying, sir, now you are teaching English, sir, like, can I get good marks in my English literature or English grammar, right? Sir, can you give practice for reading comprehensions, right? So they were taking it very seriously. This, again, I'm telling you, the language is English, the content is mathematics, right? The content is mathematics. Okay? Okay? Yeah, HM plus N. Sorry. HM plus N. Thank you. This is going to be M plus N. Thank you. Yes, not M cross N, it is M plus N. Got it. Okay. So now let me give you a whole new perspective, like I say. So let's take 2-degree expressions. 2-degree expressions. Right? F a comma b, one example, a square plus 5ab plus 4b square. Now there is a trick to master homogeneous expressions, right? There is a substitution. There is a substitution which you need to do. The substitution, it is auto focusing. Okay. Put A is equal to MB. Okay. How it will help you? Let's see. Everywhere you have to substitute it. MB comma B. Right? This becomes M square B square. This becomes 5M B square. Is it? Yes. And 4B square. Now, your B square is common and you get M square plus 5M plus 4. M square plus 5M plus 4. Isn't it? Isn't it, guys? Am I making sense? Am I making absolute sense here? Am I making absolute sense? Now, this we can factorize, right? This we can factorize. We have factorized it in the last class, if you remember. So, you have, I'm writing it directly. Okay. I'm writing it directly. B square into M plus 1 into M plus 4. Okay. Now this is the funny part. Just multiply 1B in this and 1B in this bracket. So you get MB plus B, MB plus 4B. Now what was MB? MB was A. Isn't it? And this is how you get your factorization. This is how you get your factorization. See, like, initially you have to approach it using substitution. With enough practice, you can actually do splitting the middle term. Splitting the middle term can also work here. If you are thorough with your practice, you just split it like this, right? You just split it like this. Take A common here. A plus B plus 4B, A plus B. Take this A plus B common and you are left with A plus 4B. Got it? Am I making sense, guys? So these are the two methods. With practice, you can do it with this, but initially you have to substitute it like this. This is this is what I call the ultimate method. It will always work, right? It becomes easier after using this substitution. It becomes easier to solve. You will be like the expression will look familiar, right? In this method, you may make initial silly mistakes. There is a possibility. Okay, there is a possibility. Can I make a plus b whole square? I don't think you should do it. Right? I don't think you should do it. Okay. No, don't do it. Perfect. So like, see, like what he's trying to do, but like this method is particular to this question. So we should not go forward in those methods which are particular to particular problems. What he's saying is that, sir, let's make like it like this, right? We have this. Okay. So we are left with 3ab plus 3b square. This is a plus b whole square because he remembers all the identities. This is 3b times a plus b. So this becomes a plus b times a plus 4b. But you need to understand this is particular to this method. This is particular to this method. We should refrain from using those methods which are particular to a particular problem. Okay? We should always try to see general methods. So can we do one more factorization? 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 Got it. Are we ready, guys? Are we ready? Are we ready? Got it. See, like like one student is saying, sir, why there is a difference between the sequencing of English lectures and English lectures. If you see my English lectures, it assumes that you know like 9th and 10th. I started with elementary counting techniques. Okay. Then I went on to do some basic but advanced things. In this course, I am considering that you have very little knowledge of mathematics, but you are sincere. So I am trying to teach each and everything. If you see, this is of very basic level. This is of very basic level, if you see, right? And we will add on to more lectures here. We will add on to more lectures here. Don't worry about it. Okay? Yes. So let's factorize. Fa comma b, a square minus 2ab minus 35b square. Right? Let's do it. Let's do it like this. Let's do it like this. Why it is auto focusing? I'm not sure. Acha, it is at auto kya? I made it manual now. Now it will not auto focus. Do this problem. Sir, how many of English lectures are there? So like, see, like in total, there are going to be close to 100 lectures. Close to 100 lectures. We are keeping the frequency low at this particular time, but we will increase it. In the month of November and December, I'll be taking more lectures of English courses because in total, see, like my like initial IOQM course was of 109 lectures, right? So it is going to be like that only. See, like you complete the answer. You are saying a minus 7, a plus 5, right? It should not be like this. Now, I will do with both the methods. M square minus 2m minus 35 times b square, right? So this becomes m minus 7, m plus 5. I am writing, see, like when I teach you something, I tend to do it directly. I tend to do it directly. I did not write the intermediate steps here. B square, right? Again, take 1b here and 1b here. Okay, so this becomes a minus 7b, a plus 5b, a plus 5b. Okay, am I making sense? Right, do not leave out the b. Like one student wrote a minus 7, a plus 5. No, you need to write the complete answer. A minus 7b, a plus 5b. Got it? Got it, guys. Perfecto. Chaliye. So another method is this. So see, like when I approach this problem, I just see the coefficients, right? Right? I will always see that this, see, like this, it is equivalent to this equation, right? So I would just factorize it like this, and instead of x, I'll just write a and 7b, right? I will just make certain adjustments. This is easier to see, okay? Basically the method 2, right? Now, the another method is this, completing the square. Here you can use this. This is very elegant. This is very elegant. You have a minus b square here, right? Minus 6b whole square. So you can write it as a plus b, a minus b. Okay. So you have a plus 5b here, a minus 7b here. This is the answer. Okay. Okay. Got it? Perfect. Perfect. Can you write DN in the chat? Can you write DN in the chat? Can you write DN in the chat? Can you write DN in the chat, guys? Can you write DN in the chat? Yes, it is a very interesting question. Sir, you have said that we can write A is equal to MB. But can we write B is equal to AM? Yes. Because if you see, A and B are two variables for us. And they are arising in a particular format. So my assumption is, whenever I see coefficient 1 here, I'll substitute that. This is my approach, right? Anyway, let's move on to the next problem. Question. This might be a tad bit difficult. 4a square minus 35ab minus 375b square. Right? Now this difficulty is, just a second. Oops. I think it is not visible, right? It is not visible. So I'll write a bit down. Four a square minus 35 AB minus 375 B square, right? Gupta ji ke shorts. Gupta ji ke shorts is saying you will be stopping this course in mid like all others you do. I have never stopped a course, first of all, right? I completed my IOQM course, the first which I started. After that, all the courses that I did, I started the course and I told my audience that this, like the live lectures are for initial, right? So that you can get used to it. After that, you have to see the recordings. Anyway, IOQM can be done only through recording. I am 100% certain of it. These lectures are basic, that is why some of you may be able to get it in one attempt. Otherwise, all my lectures need rewatch. Need rewatch, for sure. My JEE rank was 42. My JEE rank was 42. One learner is asking. Sit wrong. When is your IOQM nights? I am not in IOQM nights course. I am only in Ramanujan course, right? I just took one orientation class there. I am not in IOQM nights course. Hi Siddharth, how are you? So Siddharth is a good student, right? He studies in ISI and he used to be my old student. He is one of those students, I think he studied with me for at least 4 to 5 years. Right Siddharth? If you are in the chat, can you confirm? 28 good in Chandigarh, I think it is good. No, this is not the correct answer. This is not the correct answer. My physics used to be bad when I studied, but my version of bad is better than majority of students. Like I did clear physics Olympiad stage 1. So Jogirams, like these are edge cases. You are saying like you are mixing numbers and polynomials. You should not worry about these edge cases. Yes, Vedant Verma, you are correct. Vedant Verma, you are correct. So now in this thing, right, just put A is equal to MB. And then I am going to teach you something very amazing, right? So you will get B square 4M square minus 35M minus 375. See, like now one way to go about it is just use quadratic formula. So if you use quadratic formula, it becomes this 35 plus minus 35 square is 1225. How do I know it? Let me tell you, right? 35 into 35. There's a technique to it, right? 5 5s are 25. You just add 1 here, it becomes 4. 4 times 3 is 12, right? So this is one way to go. This is, I don't know, like it is Vedic math or something, but this is how it goes. Minus 4 ABC. Minus 4 times A is 4, 375 minus 375. Okay, upon 2A. 2A is 8. M is 35 plus minus, I'll just make a box of it, under root of 1225 plus 6000 upon 8. So this becomes M 35 plus minus 7225 upon 8. Now square root of 7225 is 85. Okay, it is 85. So you have 35 plus minus 85 times 8. So this becomes 35 plus 85 is 120 by 8, comma 35 minus 85 is minus 50 by 8. So this is 15 and this is minus 25 by 4. Right? So what I am trying to say here is this becomes M minus 15. These are two roots based on quadratic formula. Now if you cross multiply and match the leading coefficient, you get this. But don't you think it requires a whole amazing level of arithmetic? Arithmetic means plus, minus, divide, multiply. It needs a lot of arithmetic. So what if I tell you an amazing method, amazing factorization method? So see, like if anything is factorizable using splitting the middle term, it can be done. And majority of the problems are of splitting the middle term only. Because why would anyone, see, like if somebody is trying to check your good mathematics, why would they want you to apply a formula, right? They will check your brain, right? They will check your brain, isn't it? So let's apply brain. Let's apply brain. Let's apply brain. See, like Siddharth is saying this thing. Thank you, Siddharth. Siddharth, by the way, is a very, very amazing violinist. ठीक है? He play amazing violin. And I don't think there is any of my birthday in which I have not heard his violin. He always makes sure that he's sending me a recording of his violin. Got it? Perfect. So let's see what do we have here. Okay. So see, I had 4m square minus 35m minus 375. See, like I am very, very comfortable when the coefficient is 1, right? I am very, very comfortable when the coefficient is 1, isn't it? It's getting blur. Oh, it is perfect now. So there is some lighting issue. I believe. Just a second. Yeah, it must be fine now. 4m square minus 35. So like I am very, very comfortable when my coefficient is 1. So what I will do, I'll just take 4 and multiply it here. Right? Obviously it is not okay, but I am doing it anyway. Now see this number. See, our deal was to split this in such a manner that the product becomes this. Okay, let's factorize it. 375, let's factorize 375. It is 25 times 15, right? Or 125 times 3. So 5 to the power 3 into 3 to the power 1. And you have 4 extra. Okay. Now see, like you are getting minus 35, right? You are getting minus 35 here. So how do you get minus 35? There has to be some 0 here and some 5 here, right? That is how you get, right? So this means your 4 has to be together. Because if any of the power of 2 gets multiplied with 5, it makes a 0 at the end. So 4 has to be multiplied with 5. Then you are left with 5 cross 5 and then there is a 3. So this becomes 60, this becomes 25. Now this is brain, right? This is brain. Now we'll have to do a final adjustment also. M square minus 16m plus 25m minus 375 times 4. So you have m minus 60 here. You have m minus m plus 25 here. Got it? But you did something, you actually did a mistake here by multiplying 4. You cannot multiply 4 here, right? So this is the final adjustment. You just have to divide by the same number, right? So if it becomes this and then take LCM, you get the final answer. This is a factorization technique. This is one of the factorization technique which we use when we have like some coefficient of m square. This is the factorization technique which we use. Okay? Okay? Am I making sense? Yes. So it was blurring in between, but I think you have adjusted to it. Okay? Should I solve your book now? Yes, you can start my book. If any one of you are serious aspirants, you should definitely start solving my books. Okay, perfect. Right? I hope you have understood it. This is a very important method, by the way. Guys, this is very, very important method. Okay, now that you have factorized it, let's see some algebraic identities. Now we are on our second. So we will remember certain algebraic identities. Okay, we will remember some of the algebraic identities now. Just a second here. Yes, now I don't think it will defocus. Now it will be stable, I believe. So a plus b square is a square plus 2ab plus b square. If you replace b with minus b, then you will replace minus b everywhere. So you get this. Okay. Okay. Then you have a square minus b square as a plus b times a minus b. I am writing the most important algebraic identities. I am writing the most important algebraic identities, right? I am writing the most important algebraic identities. I don't know why it's blurring like this. It never used to be like this. Anyway, we'll have to adjust to this lecture. A square minus b square. Okay. Then a cube plus b cube is a plus b, a square minus ab plus b square. 8 cube minus b cube is a minus b, a square plus ab. I am writing all the algebraic identities just for the sake of it, so that we have everything in our record. Okay. Got it? A cube minus b cube. Then we have a plus b whole cube. So I want you to remember both types of it. So many of you must have seen this as the expression, but I want you to remember this as well. A cube in decreasing powers of a. See, I always write these expressions in decreasing power of a and increasing power of b. It helps me a lot. Right? I'm just replacing b with minus b. So here it becomes alternate plus minus. Right? So these are the identities which you have to remember for two variables. These are two variable identities. Two variable identities. Now I am going to introduce one more, which is a star. A to the power 4 plus 4b to the power 4. It is a square plus 2ab plus 2b square, a square minus 2ab plus 2b square. Can somebody prove it for me? Can somebody prove it for me? This is called Sophie Germain. This is called Sophie Germain. One of the very few things which are named after women in mathematics. Right? Right, using completing the square. Perfect. So how do we solve it? How do we solve it? I will just write this. This is a very important technique also. See, this is a square whole square. This is 2b square whole square. If I were to complete this perfect square, I would just multiply it with 2ab, right? A square plus, p square plus q square plus 2pq. So this is it. But in mathematics, you cannot add randomly. If you are adding something, you have to subtract this also. So you have a square plus 2b square whole square minus 2ab whole square. Now, some perfect square minus other perfect square. I'll use this identity, this plus this. So, this expression plus this, but I will obviously write it in decreasing power of b. Okay. Some people also remember it like this. Some people also remember it like this. Got it, guys? Got it, guys? Got it, guys? This is very important technique. So I will not bore you with these problems, right? These are assumed that you know it. We will be doing problems of this or some of these, right? We will do these things. Okay. Got it? Got it? Please write done. Please write done. If you have written all these identities, please write DN. Please write DN. Why only a small number of students are aware of RMO, such Olympiads and beauty of mathematics? Why everyone? See, like this is one such initiative which I am taking, right? I am teaching in English because IOQM English courses are not available in its complete entirety, right? In its complete entirety, these courses are not available. I'm 100% sure once these courses are 1-2 months old, we will have thousands of students watching these. I'm pretty sure of it because they are in English. My old lectures, some of the lectures are like have views in lakhs, right? It is only because it is only because Hindi speaking students give IOQM more than like other students, and it is also awareness issue. It is also awareness issue, right? Perfect. So let's solve this one. Let's solve this one. Okay. Let's try to solve this problem. Factorize x to the power 4 plus x square y square plus y to the power 4. Let's solve it. Let's solve it. It is not directly Sophie Germain, but it has something to do with it. What do you get? X by y equal to t. Perfect. Perfect. See, like now I'm not going to say, I know this is a homogeneous expression of degree 4. I'm not going to bore you with x equal to my or something, right? We are not going to do it. We will simply see it as an expression which needs to be factorized. Now I will complete the square. So if I complete the square, I need this, but I had only one x square y square, right? Right? So this gives me x square y square whole square minus xy whole square. So this is the one. This is how you write it. Got it? Got it? Got it? Got it? It's working fine, right? It's working fine, I guess. Yes, 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 yes. No drop frames. Perfect. x square plus y square plus xy, x square plus y square minus xy. Okay. Sir, which exam do you target in Ramanujan? So like, see, like in Ramanujan course, you should definitely try Ramanujan course for sure. If you are comfortable in English type of teaching, in Ramanujan course, we are teaching with Zoom classes, right? We are taking Zoom classes. Zoom classes, in Zoom classes, you get interaction also. And we are mentoring the learners. We are giving hard copy of the study material. We are definitely giving hard copy of the study material. And all those learners will be under my mentorship. So it is going to be huge course. Okay. X square plus y square minus xy. Perfect. Perfect. So let's factorize one more. Let's factorize one more expression. Okay. X to the power 4 plus 6x square plus 25. Let's factorize this. 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 IUQM results will be available on 4th of October. On 4th of October. They will be available on 4th of October. Also useful for AMC, yes. Good, very good, very good. Now you have understood it. Sir, you need to add 4x square here so that it becomes x square plus 5 whole square, and then you have to subtract 4x square, which means 2x whole square. Now sir, we can write it directly as this. Perfect, perfect guys, perfect. Perfect. Okay. Done? Yes, 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 yes. Perfect. Now this is amazing, this is amazing. We like it, we like it, we like it, we like it. Okay. Now let's introduce some irrational things to it. Irrational things to it, right? Let's factorize and simplify. I would write simplify. Simplify n plus 1 to the power 3 by 2 minus n to the power 3 by 2 upon just a second guys, 2n plus 1 plus under root of n square plus n. Right? Let's see how do we approach it. Let's see how do we approach this type of problem. There is an interesting way to go about it. There is an interesting way to go about it, for sure. Let's see if any one of you can get this problem. if any one of you can get this problem, let's see. How many super students do we have among ourselves? Let's see. How many super students? Yes, very good, Keshav. So Keshav has understood this thing. Sir, first of all, we do not like, sir, these square roots. Right, sir? So what we will do, sir, first of all, we will start on a new page because it can be a bit long. So, sir, this is what we have, right? This is what we have, okay? So, sir, we have square root of n plus 1. Let me write it as x. And square root of n, let me write it as y. So, sir, my x square minus y square is 1. Okay, sir? Okay. But here we have x cube minus y cube. Okay. Now, let's talk about denominator. Denominator is n plus 1 plus under root of n times n plus 1. So this is y square, this is x square, and this is xy. Once you write it like this, it becomes very, very easy. It becomes very, very easy because now this is a factorization. This factor will get cancelled. You have only x minus y. What is x minus y? Square root of n plus 1 minus square root of n. Oh, this was interesting. Yes. What it was? X minus y. What was it? Square root of n plus 1 minus square root of n. Got it? Got it. October 4th, like I said. Done? Perfect. So this is one such expression. This is one such expression, right? This is one such expression. It is very, very important. Like this is a tool to something very big, right? It is something known as telescopic series, which you will study in sequence and series. It is one of the most prominent Olympiad problem. But asked in usually objective exams. So IOQM, like IOQM or AIME or AMC, right? Telescopic series are integral part of that. Now, let's talk about three variables. Three variables identity. So there are very few of it which we need to remember. A plus B plus C square. This is sigma A square. Now I am introducing a new terminology. Sigma A square means, so since you have three variables here, sigma A square would mean A square plus B square plus C square. This is the terminology which I am introducing, right? Sigma AB means AB plus BC plus CA. Whatever combination of two variables you can make, you just write here. Okay. A cube plus B cube plus C cube minus 3ABC. Right? This is sigma A square minus sigma AB. This actually, I like this because it is very short. It saves our ink, right? Although this is a digital ink, but you must be writing with a ink which is tangible, right? Maybe some ballpoint pen or something of that sort, right? So that is the thing. Why it is happening like this, I'm not sure. Focus assist. This camera needs to change, I think. We need to change this camera. I'll try to do something. I will try to do something. Okay. Do you get it? So like I call it mother of all identities. This is a very important identity because, see, right, you need to remember this. This expression which we have here, right, this is actually equal to half of A minus B square. We got one question from this, right? If you remember, we got some question from it. A minus B square plus B minus C square plus C minus A square. Okay. You just multiply it by 2 and then it gets verified. There is no nothing. Sir, your favorite math book? So I have written quite a few of them. So I have written 19 books in mathematics. So they are my favorite. Right? So A cube plus B cube plus C cube equal to 3ABC. So we have two conclusions. Either A plus B plus C is equal to 0 or A equal to B equal to C equal to. Either this or this. Right? We also have A square plus B square plus C square equal to AB plus BC plus CA implies A equal to B equal to C. Why this? Why this? Because this essentially gives this. Now how can sum of perfect squares be 0? Right? Sum of perfect squares can be 0 because this is greater than equal to 0, this is greater than equal to 0, this is greater than equal to 0, isn't it? This is greater than equal to 0, this is greater than equal to 0, this is greater than equal to 0. So how come we have this? Okay. So that is why we have A minus B equal to 0, B minus C equal to 0, C minus A equal to 0, which essentially means this. Right? 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 Okay. Right? Did we get it? Are we getting it? Perfect. Okay. Perfect. Yes. So this is another identity. This is another identity. Okay. So let's try to apply AQ plus BQ plus CQ minus 3ABC. Right? Question. Factorize AQ plus BQ plus 6AB minus 8. Let's try to factorize it. Yeah, sure. Keshav, please send it. You know, right? You know, this is how you can send DM to me at the rate Prashant 42 Jain. Okay, send it to me. Do we have an answer? Do we have an answer to this? Do we have an answer to this? Right. So we will make A cube plus B cube. Now we have minus 2 whole cube, right? And then you need to write it like this. Okay. Minus 3 times A, B and minus 2. That is how you get 6AB. So there will be a problem of plus minus here, believe me. Okay. So A cube, so this becomes A plus B minus 2, then A square plus B square plus 4 minus AB, but after that A multiplied by minus 2 is minus 2A, plus 2A plus 2B. So this is the factorization. This is the factorization. This is the factorization. Okay. Okay, guys. Do it. Do it, please. Please do it. Right? Please do it. I am making one question for you all. Three, 18. Okay, so let's solve this one. This is GOAT problem. If any one of you get it, you are GOAT. This is GOAT problem, right? 27 a to the power 6 plus 10 a cube plus 1. Okay, this you need to have. This is a very difficult factorization. Like, I consider this as very, very difficult factorization. Very difficult factorization. Let's see. A cube plus B cube minus 1. You give me the answer. You give me the answer of this. If you do it, you literally have very good mathematics, because this is a problem which is made by me just now. All the other problems you can see in one of these textbooks. This is the problem made just by me. It is PJ exclusive. It is PJ exclusive. You solve it and you are good. Try. Try. A cube equal to x will not give you anything. It will not give you anything. You will try to make it into a quadratic. A cube equal to t will give you this 27t square plus 10t plus 1. But it is not factorizable. It is not factorizable. You need to use cube. And that is why I call it mother of all identities. That is why I call it mother of all identities. That is why I call it mother of all identities. That is why I call it mother of all identities. Right? That is why I call it mother of all identities. Okay? So, see, like the way to approach, I'll tell you the way to approach. Complex roots. So, we do not deal with complex roots, right? We will not deal with complex roots. Plus b cube minus 1. You give me the answer. You give me the answer of this.